So if you use KiCad to send your design to JLCPCB, you might encounter a common problem with your production files. One of the issues I have is that sometimes the placements and the rotations are off, and let me show you exactly what that problem is. So I've got a bogus PCB here. It's not got anything real on it. It's got a couple components I'm going to be using for something different, but they are some components that I've had some problems with in the past, and we want to see what's going to happen to them when I just push this up to JLCPCB and try to order the PCB. So we're going to go into the Tools tab here, External Plugins, and Fabrication Toolkit. This is one of the better plugins for sending your design off to JLCPCB. It handles most things excellently, but it does have some issues with some component placement. Okay, great. So it's created this directory with our Gerber files, our BOM, and our position file. Now we're on the JLCPCB website and we're going to order this particular component. Go down and select PCB assembly, do next. You can see the little board here with our nonsense components. We're going to add our BOM and our positions file. And this is where the problem is. The positions file was generated by the Fabrication Toolkit and it made some mistakes. So already we can see some things are wrong here. This is an op amp and you can see clearly it's rotated 90 or 270 degrees off of what it should be. That's fatal. It's just not going to work. This component is the lone component that's placed properly, and then you can see this component here is also rotated 90 degrees. This is fatal. Like if you just clicked next, next, next through this process, it might be okay with the Ethernet jack because that's placed manually. There's some components that are through-hole components that just somebody physically has to place them on there. But for a surface mount component, a pick-and-place machine is just going to follow your positions file, and there's no curing it. There's nobody who's going to step in and correct these errors after you submit go on this. So every time I use one of these components, I will have to come in here and adjust them. And I'll show you how that works. You go like this, you hit the space bar until pin 1 lines up there. You hit the space bar there, pin 1 lines up there. And then we have to go through kind of a manual adjustment process with this one. Let's look at here. I think there's little, yeah, you can see. So I'm doing the little arrows here. Okay, now we can see those pins lining up. Yeah, I'm not sure what happened to this 3D representation. It's not great, but you can see now that we've totally adjusted this thing to be in the right place. So anytime I order a copy of this PCB, I'm going to have to go through this process. And it sucks because this tool, as nice as it is, constantly forgets the positioning. Suppose I go back to the bill of materials and say, nah, I don't want to place that one component that was like working okay. I think it was this one. Maybe I don't want to place that one. I do next. I say do not place. I come back into the position review. It's processing the file and everything's back to the way it used to be. All that work I did is now gone. So frustrating. So how do you fix this? Well, the Fabrication Toolkit does have a custom field that you can put on your symbols and on your footprints that will override the position and adjust it so that when it generates the position file, it will get things right. It is a manual override, so you have to come in here and figure out the number of millimeters to offset things or the number of degrees to rotate the component. It's a process of trial and error, and I've already figured it out for these components. You'll have to do that on your own just by observing, how many degrees you have to rotate it. What we need to do is edit the underlying symbols and put in a custom field, a couple of different custom fields, so that our changes are permanent. So every time we use that symbol and then propagate it to a footprint, those custom fields get carried along. This is the Fabrication Toolkit GitHub, and they talk about the offset component rotation fields. So you can get an FT rotation offset or just a rotation offset, and I kind of prefer just rotation offset. And then you can also offset the component position. And then you also have to know that one of the arrow clicks is a 0.0635 millimeter adjustment. So you kind of count the number of clicks of the arrow you do to get the absolute position, then kind of figure out what direction you shifted the thing into. And like I said, that for me was mostly trial or error. This field for the position offset, it's a tuple. So you can see an example here where they do the X, Y offset, and the primary field is called FT position offset or just position offset. So I'm going to prefer just this straight position offset and the rotation offset fields. Okay, so let's go back into KiCad, and you can see the 4 components that I have, 3 of which are not placed properly. I just want to edit the component. This is an RJ45 connector. We don't want to edit the symbol, we want to edit the symbol library, right? We're going to come in here, and it's got this like goofy way of showing you the custom fields, and we're going to add a new one. So we're going to come in here, and we're going to add, and we're going to do position offset. And magically, I have calculated the position offset and put it into my copy paste buffer. Magic, there we go. And now this is embedded in the symbol library itself. So now we're going to deal with our op amp, and if we go in here and we hit space, we notice we just rotate it 90 degrees and it's now in a right position. Now, the fact that this is counterclockwise, you might think that that was negative 90 degrees, but no, because it's kind of the default direction that this tool wants to operate in. That counts as 90 degrees. Right? And if we look at this one up here, you can see 1, 2, 3. I had to do 3 times, so that's 270 degrees or negative 90 degrees. So for U3, we have to rotate it 90 degrees. For U2, we have to rotate it negative 90 degrees. And for U1, we're just fine. Let's go in and edit U3. Edit, and we're going to edit the symbol library. And come in here and do a rotation 90 degrees and save it. U2, we're going to edit the symbol library here and go and look at our properties, create a custom field, rotation offset, and give it negative 90. Great. Okay, so now we save that. We're going to do tools, update symbols from library. We're going to update all symbols in the schematic, and we're going to select the position offset and the rotation offset and do update. So this should true everything up, and we're going to see it did U1, U2, U3, and RJ1. Great. So let's take a look at this one now. We see the rotation offset is 90. U2, we see the rotation offset is negative 90. U1 should have nothing because it was fine, and the RJ1 should have the position offset. That's great. So we go ahead and save that, but if we go back to the PCB, we don't have the rotation offset for the other parts. So now what we need to do is we need to do tools, update PCB from schematic. Go ahead and do that, and then double check. We have our rotation offset there. Have a rotation offset there. Now the Fabrication Toolkit has the information that it needs to be able to generate the positions file properly for JLCPCB. So we're going to do Tools, External Plugins, Fabrication Toolkit, regenerate our files, and now go back to JLCPCB. Now I think we can just go back and upload our BOM and CPL again. So if we just do positions and say process BOM and CPL, great, we have the same BOM. And now look at that. Every single component here is placed properly. This one's placed properly. If we zoom under here, we can see that. If we look at U1, that's placed properly. That was always placed properly. U2 is placed properly. The pin 1 dots line up, and U3. If I stick to those components stored in that particular symbol library, I'll never have this problem again with these components and JLCPCB. It's wonderful. Bob's your uncle. Amazing. And I just want to give a little shout out to the KiCad Reddit that helped me figure this out. This has been bugging me for a long time, and I posted a question there. It's an amazingly helpful community, so thank you, other KiCad users, and hopefully this video will help you if you're having this particular problem with KiCad. Thank you very much for watching. I'm Josh, and this is Signal Drift.